we also have something called as virtualization. Now, what is virtualization? Now, it optimizes block storage in virtual environments. And how does it do that, right? So first of all, it's an appliance. The idea with software defined is, we'll have software appliance, no hardware devices, everything is software controlled. And what does virtualization do? So if you think about it, right, if you take a step back and if you think about it, on a single physical server, you have multiple virtual machines running, right? You have, as I said, I have a customer who runs 70 and some customers who run 100 virtual machines on a single ESX server or a single vSphere server, sorry. If you have 100 virtual machines running on a single ESX server and all of them are doing random IOPS, right? So they could be written at different places on the sandbox, right? Because on blocks, right? So what does virtualization do? Think about virtualization as a filter or a blender service, right? Wherein it takes in all the IOs that come from the virtual machines, from all the virtual machines that are lying on top of the vSphere server, and it sequentializes those IOs, and then it pushes down to the storage box. What does this give you? This will boost performance purely because if the blocks are sequentialized, reading is faster, because if it was not sequentialized, it was random, then to read, you would have to go to different blocks on the storage, right? But if it is sequentialized, if it goes to a blender, think about it as a filter, and after the blender, it just performance would increase to a great extent, right? So this is the benefit of virtualization. So it basically, think about it as a log-based architecture to sequentialize random I/O, right? Boost performance, increases capacity utilization, and accelerates storage provisioning, right? So this is all about software-defined storage. And let's now change gears and come and talk about software-defined networking and security. So what are we doing in the software-defined networking and security space? I mean, and what are we trying to achieve here? Like, so if you look at the past and you look at the present, virtualization in the data center. In the past, you had a physical server, right? You had a physical server, and say, for example, if a business or an application team needed needed a server, they would have to go through this process of placing an order for a server, wait for 4 to 6 weeks for the server to be shipped to your data center, then cable it up, and then install your application, right? And with virtualization, what happened? We just cut down those 10 weeks of data of lead time by just right-clicking a template, let's say a Windows 2008, taking the template of that operating system and creating a new virtual machine in instance, right, in minutes. That was the power of virtualization. That was the power of server virtualization, right? Provisioning time was cut down and made really fast. But then, it's not about just creating a new virtual machine, right? It's about adding those other components, other services, or tying other services to that particular virtual machine. And what are those other services that we talk about? We talk about VLAN networks, we talk about firewall, we talk about load balancer, we talk about IDS, and we talk about monitoring and availability. And what happened was, when so from a template, we could provision, from a snapshot, we could provision a VM in minutes, but then we add these other networking services to a particular, again, increases to days, right? And what we plan to do with network virtualization or storage virtualization is to reduce that days again to minutes. The whole idea is to bring that time down as well. So let me go back and let me talk about how is a multi-tier application provision today from a networking services standpoint. If I talk from a networking services standpoint, think about your data center again, right? If your data center is nothing but compute layer, network layer, and your storage layer, right? And let's say a business team comes to you and says that, build me, I have this new 3-tier application that I need, the web app and DB, and I need those web app and DB to be on a separate VLAN. So each tier also needs to be on a separate VLAN. So what do? as a networking team. So if I have any networking crowd out here, you would understand that I will have to first build that web tier. When I build that web tier, I will have to go down. And if you look at the networking standpoint, you have your network fabric. Each server is connected to a set of edge switches, core switches, routers, etc., firewalls, load balancers. I will have to go to each switch on the network fabric and configure that web tier from a VLAN perspective, from other networking perspective, right? And I'll have to do that, to do the exact same thing for the app tier as well. And I'll have to do the exact same things for the DB tier as well, right? So what am I doing? I'm replicating the same, I'm replicating the same VLAN or whatever the configuration that I'm doing at the networking layer over and over again, right? And this is increasing time to provision a VM or to give a VM to the business, right? And if they need if the app needs the web, since web is the internet facing, could be corporate facing, and they need to be firewall, the web and app need to be firewall, the app and DB need to be firewall, then I need to go and configure those firewall services. And if they need a load balancer, I need to go and configure those load balancers and routers if they're going outside of the corporate network to the internet. Now, all of this is a time makes, what does it do? It basically slows down provisioning. Your placement is limited, meaning when I say placement is limited, this web app and DB tier could only move within this fabric, right? On wherever that VLAN is published or wherever that VLAN boundary is. The mobility is limited. Hardware is hardware, and you're dependent hardware because you could move only to a X amount of racks or rows in your data center, and this makes the entire thing operational. What do we do? That is when, and because of this is